we're asked to find the component form of vector v with initial point 4, -2 and terminal point 1, 3. And then we're asked to find a unit vector in the direction of vector v. Determining a unit vector can also be referred to as normalizing a vector. Let's first sketch vector v on the coordinate plane using the initial and terminal points. So here we see vector v on the right. Notice to go from the initial point to the terminal point, we would have to move left 3 units, which indicates the x component is -3 in component form, and then we'd have to move up 5 units, which indicates the y component is +5, again in component form. So now we know vector v in component form has an x component of -3 and a y component of +5. But let's also determine the component form using the initial and terminal points. Let's let the terminal point be point A, and the terminal point be point B. Vector v in component form has an x component of 1 - 4 and a y component of 3 - -2. Notice simplifying, we have an x component of -3 and a y component of +5. And now to find a unit vector in the direction of vector v, we first need to determine the length of vector v, or the magnitude, and then a unit vector in the same direction as vector v is equal to 1 divided by the magnitude times vector v. So the magnitude of vector v is equal to the square root of the sum of the squares of the components, which gives us the square root of the sum of the square of -3 and the square of 5, which gives us the square root of the sum of 9 and 25, which equals the square root of 34. If we let the unit vector in the direction of vector v be vector u, we have the unit vector in the direction of vector v is equal to 1 divided by the square root of 34 times vector v, where again the x component is -3 and the y component is +5. Performing the scalar multiplication, we have the unit vector in the direction of vector v has an x component of -3 divided by the square root of 34 and a y component of 5 divided by the square root of 34. So here we have the component form of vector v, which we found 2 ways, and here we have a unit vector in the direction of vector v, also in component form. Before we go, let's take a look at the results graphically. The given vector v is the blue vector. The equivalent vector in standard position is the green vector, where in component form the x component is -3, the y component is +5, and then in red we have the unit vector in the direction of vector v, which is a vector with a magnitude of 1 in the same direction as vector v. I hope you found this helpful.